Hello, everybody. Bonjour tout le monde. Hello, bonjour. Oh, terrible. Just terrible. Vous avez pas bu de café? Vous êtes prête à vous endormir? Come on. Bonjour tout le monde. Hello. There we are. Merci. Hein? Okay, my friends, we have so little time. We have very little time. Not enough time. I was hoping for 6 or 12 hours, but they only gave us 3. It's not enough. So, my friends, I should say first, of course, I should say first that je suis heureux d'être ici. Merci de m'avoir, merci d'être venu me voir parler sur Cloud Native Java, mais ma langue maternelle c'est anglais, alors je vais donner ce talk en anglais, okay? Thanks for coming. I'm so happy. I mean, it's springtime outside. It's so beautiful. It's so nice, and yet we are here in this dark room, you know? And I still appreciate it. I appreciate that we're talking about spring instead of enjoying spring. So there's that. We will cover a lot of things today, my friends. We're going to cover so much. So I encourage you to record that URL, that URL up there at the top. Keep that for your own reference, for your own edification for later on. So if you have questions or comments or feedback, if you have ideas, you can check the code, right? You can check the code. While people are coming in, I'm just hoping that they'll record that URL. Before we get started, before we move too far down, I want to also say that Pivotal is hiring. You know, if you're interested, if any of you want to work on some of these projects, some of these have head count right now. They have the ability to hire. Some not yet, but later in the year. So inquire. You know, we'd love to have encouraged, inspired people working on the team. Now, if you have questions, if you have comments, if you have ideas, if you want to talk, if you are confused about anything, I want you to please reach out to me, okay? Reach out to me. I'm on the internet. I'm happy to help. How many of you, I'm just curious, how many of you are on Twitter? Twitter, 2018, Twitter. All right, that's pretty close to the majority. That's great. Most places I go, what is Twitter, you know? But I think recently, you know, there have been more reasons to leave Facebook, and what's left? Twitter. You know, now we know. You know, you can only one place you can go is Twitter. So there's that. What about email? How many of you are using email? Email. Is anybody here using email? No. Good. Okay. Moving on. We are in a post Slack world, my friends. I don't know what that means, but it means who cares about email? What about fax machines? Anybody here using fax? Fax. Okay, good. So we don't have that. A little bit about myself. My name is Josh Long. I'm a Spring developer advocate on the Spring team. I'm an open source engineer and contributor to a number of different projects. I've worked on a lot of different projects. I have been a contributor and a committer to a lot of different projects for 10 years or so now, right? A decade. And I have the, you know, the dubious, the questionable honor of being the number one, top-ranked, most prolific, most highly lauded, most acclaimed, most famous contributor of bugs. But still, number one. It's not the best, but it's something, okay? And there's that. I'm a Java champion, of course, and I do, as part of that, I spend my time trying to help people build better software using the JVM and using Spring and using all these great technologies. As part of that, I do these training videos. So if you have access to Safari, you know, Safari, it's an online, all-you-can watch, you know, buffet-style subscription like Netflix, but for technical content. There's videos there, right? And they're same flat rate, so you can watch things on continuous delivery and building microservices with Spring Boot and Cloud Foundry and all this, you know, all this cool stuff. There's videos there, a lot of which was done with, oh yeah. A lot of this was done with other presenters in the ecosystem, right? So Marcin Grzesiak is the lead of Spring Cloud Pipelines. He's our continuous delivery guru on the Spring team. He and I did a video. I did a video with Phil Webb, the co-founder of Spring Boot. He and I did a video, you know, etc. Josh McKenty, the creator of OpenStack, who works on Cloud Foundry. He and I did a video. So there's a lot of cool stuff there that we did together. And I have just finished, last year, I finished finally this book I have been working on. The last time I was here, it was not done. And the book took a little longer than I expected. Okay, that book took a little bit longer to finish. Right? Some of you may remember that I was talking about it last year, and the book took a little bit longer to finish than I had expected it. Okay, I'm just going to go ahead and say it. I'll just be honest. Okay, it took a little longer than we thought. My co-author and I, we said, well, software estimations are a science now, right? No, of course not. But we said it's a science now. We are for sure. It'll be 6 months, no problem. 6 months, and then we'll be done, and then we can go home and relax and not worry about it anymore. And it took a little longer. It took a little longer than 6 months. It took just a tiny bit. It took 2 years. Okay, it took 2 years. It took 2 years to finish this book. This book took a little bit longer than 6 months. It took 2 years, and the reason is really quite understandable, right? I mean, I don't want to. In English we say air my dirty laundry. I don't want to share the bad, behind the scenes details. But we're friends. I'll go ahead and just say it. I'll just go ahead and say, my co-author and I, we had trouble with the publisher, O'Reilly. Right? The book. It did take a little while. It took a little longer than we thought. It was supposed to be 6 months, and we thought, okay, 6 months. And yes, it's a busy, very complicated topic. We're talking about Spring Boot and Cloud Foundry and Spring Cloud and Spring Cloud Data Flow and all these moving targets, these things that change all the time. But really, most of the delay was because of this unfortunate dynamic that my co-author and I had with O'Reilly. You see, there's a lot of back and forth, a lot of arguing with O'Reilly. I don't want you to think a bad thing about O'Reilly. They're a great company, but we had a lot of debates. Okay, I'm just gonna go ahead and say it. We had a lot of debates. We spent 18 months trying to arrive at the animal for the cover. Okay, that the animal for the cover took 18 months. That's why it took so long. Okay, and we went back and forth working with each other to try and resolve this question over a year and a half. And it took a long time. But the people at O'Reilly are very, very smart, very, very, very gifted cover, people. So they eventually, working with us, they eventually arrived at a bird. The bird that you see on the cover there is a blue-eared kingfisher. Blue ears. Did you know birds have ears? It's not something I really noticed, but I suppose it makes sense. Anyway, it's a blue-eared kingfisher. It's a bird that is indigenous, or as we would say in English, native to the Indonesian Java Islands. So the Java Islands in Indonesia, they have this bird that is only found in those islands. It's a bird that is indigenous to the Indonesian Java Islands, and it's a bird, and birds fly, yes, through the clouds. So it's a bird that is native to Java that flies through the clouds. It's a cloud-native Java bird. It's a bird that flies. Never mind, it'll come. It'll come. Give it a moment. Give it some time. It'll arrive. And of course, I work at Pivotal. And at Pivotal, we have a lot of great open source software. We love open source. All the time I talk about these projects. We love these projects. We care about the open source software at Pivotal. But at the end of the day, let's be very clear. It is not the main reason that we are here. It is not the main reason that I am here. It is not the thing that motivates people like me. It's not the reason that I spring out of bed in the morning. Instead, what I care about, and what we all care about at Pivotal, more than anything, is helping people build better software faster. To help them take an idea and then move that idea from a concept all the way to the customer as fast as possible, from idea all the way to production. How quickly can they do this? How quickly can an organization take this idea and take it from just a simple idea and go from from product management to user experience to developers to testers to administrators and then off into production? And we know that a lot of organizations struggle with this. They know that they need to go faster, but they struggle with how. They look for ways to go faster, and they look at their existing code bases. A lot of these companies are lucky. They are fortunate to be successful. They have had large applications that they have built over these many years, and those applications have served them well. These large applications are a good problem to have. But the larger the application, the larger the team. The more people working on the team, the more expensive any change to the code is, because it requires more coordination, more communication between different people in the team. This slows down progress. As things change, it becomes harder to coordinate with other parts of the team. So these organizations, they look for ways to go faster, and they understand that it has something to do with the size. They say, oh, well, these startups, they're able to go fast, they're able to go quickly, but that's just because they're a startup, they're small, right? And that doesn't really, that's not really correct. It's misguided. You're missing a very important point. A small startup is able to go quickly, yes, because it is small, but that doesn't explain companies like Amazon and Netflix and Google. These companies are massive, huge, and they're still able to go quickly. What's the difference? Well, obviously it's the size of the team, not just the size of the organization. It's the size of the team developing the software. The smaller the team, the more readily these teams can deliver software. And so the question is, how do you get small teams? Well, you have to divide your code. You have to break apart your large existing application, your monolithic application. You break this apart into smaller pieces. The smaller the piece, the more readily, the more easy somebody can take an idea and then move it and test it and deploy it and scale it up and so on. And of course, it's not easy to identify where to break this monolithic application. There's a great book by Eric Evans called Domain-Driven Design. How many of you have read this book? Domain-Driven Design. Oh, it's a good book. You should buy it, read it to the kids. It's amazing. It's a great book for bed, bedtime. So it's a wonderful story. And it's in this book, they talk about something called a bounded context. A bounded context is a part of the domain model that does not need other parts of the domain. If you can identify a bounded context, then you have a natural place to break apart your application into smaller batches. It's hard to do this, but once you have done this, you have a natural place to do this. You have a natural place to break apart your application. So what you're looking for here is a small code base that you can deploy independently of other parts of the organization. You don't have to ask them for permission and coordinate with them. You want autonomy, right? You want the ability to go faster. So you look for small, singly focused, independently deployable, reusable, right? It has to be reusable by itself, bounded contexts. Well, when you think about independently deployable today, what does that mean? Well, it means it's going to be a network service, isn't it? It's going to be a service that talks to another service over the internet. Unless you're doing like OSGI. Don't do that, right? So it's small, singly focused things that can talk to each other over the network. This basically means a microservice. Small, singly focused, independently deployable, reusable, bounded context. This is a microservice. And when you move to microservices, there are some benefits. The first benefit, of course, is the ability to go faster as an organization, to deliver better software faster, right? This benefit is the number one reason to move to this architecture. And it's not a new idea either. It's a very old idea. We've all heard about Mel Conway. How many of you have heard of Mel Conway? Mel Conway, in the 1970s, he understood, he said that software reflects or it mirrors the communication of different teams in an organization. So if you have an organization and you have different teams in that organization, and if they are doing a poor job, if they're having trouble communicating, your software will show that break, that trouble. It will reflect the dysfunction in the organization. If you want to fix the software, you fix the organization. The software will improve. So if you have two different teams and they're not talking to each other, or they have a well undefined component boundary, that will show up in the software. They've done a lot of studies where they looked at open source software and they compared it to proprietary software. They looked at open source software and then compared it to proprietary software, something of the same function, but open source, right? Imagine you had the opportunity to look at the source code from Microsoft Office. Opportunity. Opportunity. Imagine that you had that privilege. What do you imagine you would see if you were to stare into the source code for Microsoft Office? I don't know. I have never seen it. I'm still alive. Obviously, I don't know. But if you could see it, what do you think you would see? What do you think you would see if you saw that and then compared it to something of the same form, the same function in open source as a hypothetical? Maybe you have Microsoft Office versus OpenOffice. What you would realize is that the proprietary software tends to be far less modular than the proprietary software. And this makes sense if you think about it. You've got people working in open source, and they're in different time zones, different geographies, they speak different human languages, and they contribute at different cadences, different opportunities. Some people contribute in the weekend, some people early in the morning before they send the kids to school, some people in the evenings after dinner before bed, some people not at all for weeks, and then they come back and they burst and they contribute a lot, and then they disappear again. Right? The contribution model for open source is very different. People are not in the same room. They're not in the same office. They don't go to the same place every day. And so for them, the cost of coordination is expensive. It's very expensive. If I'm in California and I'm working with somebody in China, one of us is going to have to stay up very late or go to bed or wake up very early to be able to talk to each other, on a phone call. And of course, it's even more difficult to get in the same room. So eventually, any changes, any communication that needs to be done has to be done over these very slow email threads or Slack or something, whatever the latest thing is. So the cost of coordination is expensive. What you get by moving to microservices is the ability to go faster. There are other technical benefits, of course. Of course, there are other benefits. You get the ability to use the right tool for the job. You get the ability to test things more easily. You get the ability to use whatever backing persistent store, like a database, that you want for the job. You have a lot of technical benefits, but the real benefit is the ability to go faster, to deliver software to the market, and to give software to the customer where you can get feedback that validates your investment in that software. Now, it's not a perfect approach, of course. Nothing is free. When you move to microservices, there are also pains. I call these the hemorrhoids of cloud computing. Do you know what a hemorrhoid is, my friends? Hemorrhoid? It's a real pain in the When you move to this architecture, you will have at least two big, okay? The first pain that you must be able to address when you move to this architecture is how quickly can you build a new service? How quickly can you address all the requirements to build a new service? If it takes forever to do it, then you will not do it. I don't blame you. I understand completely. Everybody, all of us, must make a judgment. We must say, oh, well, I want to do this. This is the right thing to do. But it'll take too long, and we have to be in production soon. So we cannot. We'll do something else. We'll do, choice number 2, right? We'll do something that is not as good as the ideal. So all of us have to make these calculations in our head when we do anything, when we commit to doing anything. And if doing the right thing is too difficult, then we won't do it. It's rational. When we talk about rational in this case, what we mean is that even if we don't like the result, we understand the result. Imagine that I picked up, a tea carafe. I had hot tea, very hot. And I pick it up with my hands, and it burns. And I drop the tea. And the tea, it breaks the glass. And there's a broken cup on the floor. That's a very bad result. But it was a mistake. I didn't mean for that to happen. Nobody wanted that to happen. you would do the same thing. You would burn your hand and you drop it and go, oh, you know. So the result is bad, but can you blame me? Of course not, right? I understand that. This is the reason that people, these concessions, these compromises, are the reason that PHP is a thing, right? These terrible, terrible design decisions that people have to make over time. So, we have to get past all that. We have to make doing the right thing the easy thing. And if doing the right thing is not the easy thing, then you won't do it. What if I wanted to build a service that has data, and I want to store that data in a service, in some sort of database that is built for, let's say, unstructured data, like documents? Well, the right thing to do there, of course, is to use something that is built for that, like Couchbase, right? Maybe I want to store my data in, I want to store geographical data, geospatial data. The right thing to do there is to put my data into something that is optimized for that, like a GIS server, right? Maybe I want to store binary data. I want to store binary data because I want to upload photos, that kind of thing. I have a service that manages photos. The right thing to do is to use something like Amazon S3 or React CS. These tools are built for this. They're a scalable sort of file system, right? But it's so much easier to just say, oh, never mind, I don't have enough time to learn how to use these tools, to deploy it, to scale it, to manage it, etc. So we don't do it. Maybe I want to build a service that manages relationships, interconnected data where the relationships have meanings. The right thing to do here is to use a graph database. Ironically, relational databases are not great for relationships. It's a little awkward. Maybe I want to build a service that loses data for no reason at all. The right thing to do here is to use MongoDB. But again, we are always in a hurry. We always use these other tools that are not the right fit for the job because we don't have enough time to use the right tool for the job. So we need to make doing the right thing as easy as possible. Most organizations that I have spoken to, not yours, of course, not yours. I know it's not yours, but most organizations that I have spoken to have a terrible wiki page. And again, I know it could not be yours. Most organizations have a terrible wiki page with 500 easy steps to production. These 500 easy steps are all the non-functional requirements that you must do before you can deliver one line of useful business differentiating functionality. Imagine you wanted to build a hello world. It just says hello world or bonjour le monde. That's it. It just says that. What would you have to do to deliver this into production? What would the checklist show you? Observability, heartbeat detection, security, infrastructure, containers, virtual machines, load balancing, DNS, routing, Linux patches, all this other stuff. How quickly can you get past all of that? If it takes forever, then you won't do it, and I understand. So we need to make doing the right thing the easy thing. That's the first pain. These days, I talk to organizations about technologies like Cloud Foundry and Spring Boot and Kubernetes. These technologies are built to handle these kinds of concerns. Now, once we have gotten past that first pain, we now have another problem. We have a proliferation of services, lots of small services talking to each other. And these services are distributed. They're over the network. And so there is complexity. If the services are disturbed, if the network connection is disturbed, then we have trouble communicating. This complexity is inescapable, but you must be able to use simple primitives, simple tools to address this complexity. And there's a lot of this complexity. I talk to organizations about Spring Cloud. Now, increasingly, what we are starting to see in the last 10 years is that as when people move to this architecture, when they move to this architecture and they start doing more and more over the network, they introduce complexity of I/O. The input and output between services starts to become very expensive. We start to see that there are limitations to the way that Java has historically dealt with input and output. And we only see this as we start to move more and more data over the wire, over the network, especially when we move to microservices and big data, right? Think about the way that a traditional web application based on something like the servlet specification and Tomcat and whatever works. You have a server socket. The server socket accepts incoming requests. As incoming requests come in, there's a thread pool. It spins a new thread out, or it creates a new thread. The thread processes the request, and it produces a response in the same thread. Threads are very expensive on the JVM, and in any kind of operating system context, any kind of operating system thread is expensive. So we have to reuse our threads. We can't just create an infinite number of them. They're very expensive. This is okay as long as the production of a response takes a very little amount of time, very small amount of time. If it takes a long time, then it is possible that we will not have any threads able to accept any more incoming requests. That's a problem. And this doesn't need to be a problem. You see, in this scenario, we have linked the production of responses to the number of threads in the thread pool. But that link does not need to be there. It has been possible for 30 plus years to tell the operating system, hey, operating system, here is I/O. Here's a file descriptor. When there is activity on this I/O, tell me. But in the meantime, while you are processing this, I will do something else. This is asynchronous I/O. And this has been available for a long, long time. Even in POSIX, P-O-S-I-X, we have a select. You can give it a bunch of file descriptors, and it'll return when there's activity. This has been there forever. And so it's a shame because we have this support in the lowest levels of the operating system, but we haven't really taken advantage of this. Java has for 15 years. We've had Java NIO since 1.4. Java NIO gives us support for asynchronous I/O, channels. Now, this is the solution, but are you all writing your code using channels and input streams, or using channels in asynchronous I/O? Do you do web programming using channels? Do you write your database code using channels? Do you do security using channels? Of course not, right? This makes no sense. I don't think you are doing that. I don't think you are doing input stream and output stream either. It makes no sense. You think about your business logic in terms of the domain of your application. You think about it with your types, the objects in your business logic. And you think about it in terms of aggregates that let you work in that model. Well, historically, the thing that we use for this aggregate is a collection. A collection gives us the ability to say, here is a series of records, of items, of objects. It's finite. And this maps very nicely to synchronous I/O. Right? If I have a finite, limited number of records, I can send the whole thing back in one response very quickly. But this model starts to become problematic when you move to big microservices where you have lots of data, or potentially unlimited amounts of data, and where you have data that may arrive eventually. It's not here now. For example, with WebSockets. Right? WebSockets are server-side push, where you're pushing data down to the client. So we need to be able to expose our domain. We need to be able to model our domain in a way that lets us take advantage of this asynchronous I/O. Imagine that we had something like this. We had some way, some computational metaphor, some way of describing a potentially unlimited, unbounded amount of data, asynchronously available, unbounded amounts of data. If we had this thing, would that be useful? I mean, imagine that Spring and Jackson and Hibernate and all these technologies that have been around for the last 10, 15 years. Imagine if they did not understand what a Java util collection is. Imagine that JDK has a collection type. It has lists and sets and all that. But Spring and Hibernate and all these things didn't know what they were. It couldn't use them. It threw an exception whenever you used a collection. You wouldn't use this, would you? If the frameworks above didn't support a collection, then you would very, very, very aggressively stop using collections because it would be pointless. You'd run into problems. Well, whatever thing that we define to support unlimited amounts of data has to be supported at higher levels, at every layer in the stack. Otherwise, we won't use it. So there is something that supports what we're trying to do here. There's a specification called the Reactive Streams specification. You see, there have been a lot of different companies who have tried to solve this problem. They have tried to create a solution or a computational metaphor, an API for working with asynchronous, unbounded amounts of data. Microsoft Research created the RX extensions for .NET. That inspired RX Java from Netflix. You've got Lightbend, TypeSafe. They have Akka. You've got the Vertex project over at Red Hat. And in 2011, you have Reactor from us on the Spring team. These different projects all solve basically the same problem. They solve this missing computational metaphor, a asynchronous collection, if you will. And it's a common enough problem that we created a sort of de facto specification called the Reactive Streams specification. We created this in 2013 or 14, I forget the year, a few years ago. And this is the solution. This specification has 4 types, 4 very simple types. We have the publisher. The publisher publishes items. You have a subscriber, which consumes items that are published by the publisher. When the subscriber subscribes to the publisher, it is given a subscription. So that's the third type. You have publisher, subscriber, and subscription. The subscription is a connection. It's the session, if you will, between the publisher and the consumer, and the subscriber, I mean. Now, the subscriber is valuable because the subscriber can use this subscription to tell the publisher to slow down. Think about asynchronous IO. You have this thing that's going to call you whenever there is data. Well, imagine that there is 10 terabytes of data. You know, a lot of data, all at once, very suddenly, very quickly, a whole bunch of data. Well, I don't want for this asynchronous IO to just say, here, hold this, here's 10 terabytes of data, and then my code has to process it all at once. It wouldn't work, right? I need to be able to say, no, hold down, slow down, right? This is called flow control. And when you build any kind of basic protocol using UDP or TCP, you must think about flow control. In the world of reactive programming, this flow control is called back pressure. It is how you build systems that will safely process data. You slow down the consumption of data. So publisher, subscriber, and subscription. There's a 4th type. The 4th type is very simple. It's called a processor. It is an interface that extends publisher and subscriber. It is a source and a sink. That's it. Now, that's the Reactive Streams specification. Is that enough? Are we done? No, still no. Because again, you need more support on top of that. This Reactive Stream specification is sort of like a Java array. It's nice, but it's still very simple. We want support for traversing the data, for filtering, for transforming, etc. This is why you have collections, or you have, in this case, different projects like Reactor from the Spring team, from Pivotal. They provide operators to process this data. Is that enough? I say no, still. Because nobody knows about it yet, right? What good is Reactor if you cannot build web applications? What good is it if you have no access, no support for data processing, data access? What good is it if you have no support for security and all these other things above that? So in September of last year, we released Spring Framework 5. This is the first version to natively support reactive programming, end-to-end. Since then, we have released Spring Data K, which is reactive data access, Spring Security 5, which is reactive security, and Spring Boot 2.0, which pulls together all these things. And we are working on Spring Cloud Finchley, the new release of Spring Cloud, which also supports reactive programming. So today, my friends, we're going to talk about all of that. We're going to talk about it, but we have first a very important question to answer, a very important question that we must answer first. Java or Kotlin? Which one would you like to see? Who wants to see Java? Okay. Who wants to see Kotlin? What about both? Who wants to see a little bit of both? I feel like everybody would be happy if I just did a little bit of both. Okay, let's do both. So, my friends, we have to, we're going to build some software today, as always. Wow, this is my back. Okay. We're going to build some software today. Okay. Here, this is my second favorite place on the internet. How many of you know this place? Start.spring.io. It is my second favorite place on the internet. My first favorite place, of course, is production. I love production. You should love production. You should go as early and often as possible. You should bring the kids and the family. The weather is amazing. It's the happiest place on earth. It is better than Disneyland. But if you have not gone to production, then you can begin your journey here at start.spring.io. If you need inspiration in the early morning before your tea or coffee, start.spring.io. If your children are restless and cannot sleep, start.spring.io. And if you suffer from indigestion after a long night of alcohol abuse and PHP, start.spring.io. So we're going to build a new application here, my friends. We're going to build a new application using Java. I'm going to choose Kotlin. But the nice thing about Kotlin is that I can merge them together. I can have Java code in the same project as my Kotlin one. So if I configure it with Kotlin, I can do 90% Java, but then I can show you where it's appropriate, the Kotlin APIs. And we're going to build a new application. We're going to build a new service. I use the same domain all the time because I don't care about the domain. I'm going to call this the reservation service. And we're going to use Spring's reactive web support. This is different from the web. Okay, so reactive web is what we're going to choose. We're going to use a actuator for observability. We're going to use the config client for centralized configuration. We'll use Eureka for service registration and discovery. We're going to use Hystrix. We're going to use Kafka, Apache Kafka for messaging. We're going to use Spring Cloud Stream, Reactive Spring Cloud Stream. We're going to use, what else do we want? Reactive Web, Actuator, Config, Eureka, Kafka, Zipkin for distributed tracing. Now, we need some sort of persistence option, some way to save our data. And we could switch to the full version here, and we are given many different choices, right? We see that there are many different SQL options, Postgres, MyBetis, Juke, Flyway, or all these different SQL options, but none of them are reactive. So we will not use that. Right now, there is no good story, there's no good support for reactive JDBC-based access. Not yet. Hopefully, one day, 1 year. I'm encouraged, I'm hopeful about what I saw coming out of Oracle in the last few Java 1s. Last year, they talked about a new reactive JDBC driver, so maybe one day before we die, this will happen. But for the moment, there's nothing really solid, okay? So we don't want to provide a reactive facade on top of something that is blocking and synchronous. There would be no point. It would be a more complicated API, and it would not be more performant. So why? Just if you want to use synchronous blocking JDBC, you can, but you have to care for the fact that it is synchronous and blocking. Instead, for our purposes today, we will use a reactive NoSQL option. And there's a lot of choices here that are, we have a lot of different NoSQL options, but only a few reactive NoSQL options. We could use the reactive Redis support. That's a fine choice, but it's not the right domain model. It's not the right type of data for the thing that we're trying to build here. So we'll come back to that later. We could use the Cassandra support, reactive Cassandra. That's a nice choice as well. I don't have Cassandra on my local machine, but maybe later. Okay. We could use reactive Couchbase. It's another good choice. That would also work, but we don't have it on my machine, so that's not something that we're going to use. So we're left with reactive MongoDB. Because when you want to lose your data, and you want to lose it reactively, there is nothing better than reactive MongoDB. So we'll add that. Now, I'm happy with my selections. And I'll go ahead and generate my project. I have a few things that we should spend some time talking about here. There are some drop-down menus here. These drop-down menus are, they imply a choice, but really, there is no choice. The first drop-down menu is the choice of Java version. Now, we have selected 8 by default. Spring Framework 5 and Spring Boot 2.0 don't support Java 7. It's Java 8 only or better. So it's reactive, it's functional, right? It's going to be functional all the way, baseline. So you cannot choose Java 7. And I would wait, if I were you, I would wait for one of the new versions, Java 11 coming out later this year. Java 11 will support, it'll be a long-term support, basically, long-term release. So that's the one I would deploy today if you had a choice. Java 10 is a nice choice. All of these are nice choices, but the stable one is going to be later this year. All right. So I would stick with that. Then we have the choice of packaging, and here people get confused. They don't understand when and where to choose which. So I will do my best to explain here and now. If by some terrible accident of physics, you are somehow transported to the distant past, far, 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 far beyond modern help, then choose .war. But if you're here with me in 2018, then choose .jar. This is a big part of my personal philosophy of make jar, not war. So, I will leave this as is. I will leave my selections as they are, and I'll generate a new project. In the downloads directory, I have this new zip file. I'm going to open this up in my IDE. I'm going to use IntelliJ. It's a fine choice, but anything that supports Java 8 will work. How many of you use IntelliJ? I'm just curious. Okay, very good. How many of you are using Eclipse? Rock on, very good as well. I love Eclipse. What about NetBeans? Also very cool. NetBeans? I love NetBeans, right on. What about Emacs? Are you here, sir? Where's that guy? I don't mean guys. I mean there's one human being, one specific human on the planet. It seems like every city, every single city, country, and continent I go to, he's always there. I say, who uses Emacs? And he says, I do. And then he leaves to go troll me again in some other city or country or continent. The same human being. Troll. Anyway, is this too small, my friends? Can you see that? I get a feeling that's a little small. Yeah, is that too small in the back? Yeah, wow. Your monitor here is really good. I didn't realize it was so good. Whew. Okay, what do we got here? Normally, I don't have to downsample once I'm on stage. So we want 1610. Well, what does that get us? And okay, make this a little larger, 22. What about that? It's okay? Very good, thank you. You see, it's Linux, it just works. No problems. Very good. Now, we have a Spring Boot application here. You can tell because it says, well, it says Spring Boot. I mean, that's how you can tell. That's how you know. It says Spring Boot application. So it's a Spring Boot application, and we're going to go ahead and write most of our code here in a new Java class. Actually, I'll create we're going to manage data. First of all, this application is going to manage data that we're going to store in the database. Okay. Now, before we get started, I'm going to go ahead and comment out some of the things I don't need just yet. I'll comment out the Spring Cloud stuff first of all. So Spring Cloud, Kafka, all that stuff. I'm going to go ahead and comment this out so that we can come back to it later. Okay. Now, I'm going to build an application that manages data, and I'm going to give you a very simple introduction to Kotlin here. We're going to create an object that we're going to persist into MongoDB as a document. So I'm going to create a record called reservation. Whoa, reservation, like so. And it's going to have a field, private val ID, string question mark equals null, right? And another field, private val reservation name, string question mark equals null. Now, let's talk about this. First of all, I have a field here, private, so that looks fairly familiar. I have a val modifier. This means that it's an immutable final field. And then I have the name of the variable and the type of the variable. So it's, backwards, other way around. And then here we have this question mark. This says that this variable is nullable. It can be set to null, or it can be non-null. It has to be non-null. You see, if I remove this, the compiler is upset. It says, why? Now this looks okay, but this is very Java, very, very Java style. It's not really Kotlin. In Kotlin, if I wanted to create, if I wanted to use this, I would still have to create getters, setters, equals, toString, all that kind of stuff, and a constructor. So let's use Kotlin instead to do this a little bit more elegantly. We're going to create a data class. We can define the constructor here. And in the constructor, we're going to say that we have two fields like this. There we are. So we have this reservation entity. It has a constructor that takes two arguments, ID and reservation name, and the default value is null. And we're going to make this into this. And so this will actually generate a class that has getters and setters and a constructor and two private fields and an equals and toString. All of that comes for free here. Okay? And now we're going to be able to create a server. We're going to create a, let's say that we do this. Let's see, how do we want to do it? I guess we can do this over here. We'll say we're going to create a Java class so that it's mostly in Java from here. Let's say we're going to have a app. Actually, yeah, we'll do this one in Kotlin. We'll come back to it and do the next one in Java. So we're going to create a application that manages data. It's going to persist and write data to the database. So I'm going to create a Spring Data repository like this. Spring Data repository. And I'm going to extend the reactive Mongo repository. And the reactive Mongo repository is going to manage entities of type reservation whose primary key is of type long. Now, I don't have to extend. I don't have to actually keep these parentheses. It's still a valid definition. Just like this is a valid class. It's a top-level class. And this is a function, top-level function. In Kotlin, you have functions and you have member functions, which are like methods. But everything is a function. Okay? I don't need to put this function inside of the class. Now, I want to be able to save data using this repository. This repository is just like any other Spring Data repository, except that it supports reactive processing. And you can see here that this is just a regular Java interface. You can see that it looks very familiar, but it's slightly different. It takes publishers of data. This is the reactive streams publisher that we talked about earlier. The publisher has one method, subscribe, which takes a subscriber. The subscriber has several methods, onSubscribe, onNext, onError, and onComplete. The onSubscribe method is the one that gives you the subscription. And the subscription has this method, request, which you can use to request more records. So there you are. That's basically the entire reactive streams specification. Our repository returns these two types here that are a little different. These are different from what you have seen before. A mono is a reactor. It's from Reactor, not the reactive stream specification, but from Reactor, which is our project. And it extends or it implements publisher. So a mono is a publisher that produces 0 or 1 record. A flux is a publisher that produces 0 or an unbounded number of records. It's 0 to infinity or 0 to 10 or whatever. Why the difference? Why would you have two different types? Well, imagine somebody gives you a publisher and says, here, draw a user interface for this. Should you show a table with all the records? Or should you show the details for one record? Well, if you are given a mono, then you can think of it kind of like a future. So it's just one record. If you are given a flux, then that is a number of records. So that would be the overview page, right? Now, we have this reactive repository. It supports sorting and paging and all this kind of stuff. create, read, update, delete. Now, I want to create a bean that gets processed when the application starts up. And I'm going to use that as an opportunity to write data to the database. So here, I'm going to use a data initializer. I'll say data initializer. And it's going to implement this application runner interface. Application runner interface is a callback interface. When Spring Boot starts up, it's going to call the application runner interface and call the run method here, and we can use that run method as a chance to write data to the database. And I'm going to tell Spring to inject the reservation repository here in the constructor. I'm injecting a field in the constructor. And now I'm going to write some data to the database. I'm going to say flux.just, and we'll use some names. My name is Josh Ashante. What's your name, my friend? How do you spell that, my friend? Vincent. Sorry. Miss, what's your name? How do you spell that, my friend? Jemm? Ah, okay, Jennifer. Oh, very good. Okay, you're so different. It's so different. Okay. Let's see. Who wants to be? What about you, buddy? How do you spell that? D? Rudy. Okay, very good. Nice to meet you. And who wants to be my next victim? Sorry, volunteer. Miss, what about you? Yes. How do you spell that, my friend? I-N-D? E? Like that? Okay, very good. Nice to meet you as well. Three more. Yes, sir. Back there, who raised your hand? Like this? Very cool. Nice to meet you. And the other one who raised the hand? Like that. And you in the bright pink shirt, my friend. How are you? Hi. How do you spell that? What is it? Barry, like this guy. Very cool. All right. So nice to meet you all. Thank you so much for that. So I'm going to have now these names. Whoa. Sorry. Val, names. Okay. And this is just a publisher, after all. It's a publisher of string names. Okay. And I can leave it like that, but I'm going to choose to use type inference, right? And I'll just leave it off. And now I'm going to say, I'm going to map each one of those fields. I'm going to say map, parenthesis, and I'm going to create a lambda. I'm going to define the lambda like this. I'm going to say, take each name and create a new object. So here, I'm going to pass in null for the ID and then pass in the name. Now, here, I don't have to say new. There's no new keyword. It's just this is the same as saying new. I use this because that's the ID field, right? The ID, but I don't have to specify that. In fact, I can just drop it and just say reservation name equals, right? Now, the problem with this code, I mean, well, first of all, reservations, if I say that this is a reservation, it's a publisher of reservations, right, like this. I could leave that code like this, but there are several problems with this. First of all, in Kotlin, if you are passing in a lambda as the last argument or the only argument, then you do not need to have parentheses. So I can get rid of this. Also, in this case, I have a lambda with one parameter, and I created a variable name, but it's such a common thing that you can remove that and just say it, all right? So now, I'm going to change each, I'm going to save each one. So I'm going to say reservations dot map. Oh, I need to do type inference, or actually, this is actually a flux. So now I'm going to say map. I'm going to map each one of those into a record that I save in the database. So I'll say reservation repository dot save it. All right? And that's the saved records. Now, what happens if I run this code just like this? What will be the result? Sorry? Yeah, somebody got it. Nothing, exactly. This code is like me, very lazy. You must force it to act, right? And in order to do that, in the reactive world, you subscribe to the data. So I can say saved.subscribe, like that. Or this, right? I can print out the data. Now, this code will work, but there's a small problem with this. How many of you know the expression in English that a broken clock strikes true twice a day? So you have a clock, you know, and the hands are not moving. They're not moving, it's broken. And so even though the hands are stuck like this or whatever, like this, even though it's stuck like that, in the morning it is correct, at least one instant, and then in the evening as well, right? So it's correct twice in the day, even if it's broken. Well, this is the same is true for Mongo. You see, sometimes, by accident, data will get through and be persisted. I know that they work hard to delete all your data all the time, but sometimes data gets through. So we want to clean up our data. I want to delete everything first, like this. Well, of course, this is going to return a mono. You see, delete all returns a mono, a void. So I need to actually, I need to force it to act. I want this line to execute before this one. I could say, oh, let's subscribe like this. Well, that's not quite the way to do this, is it? Because this line, there's no guarantee that this line will finish before this line. You see, this is asynchronous. The callback in the subscribe method can be run on a separate thread. Instead, I could choose to block, right? But this is a terrible thing. I showed this code to my partner, Tammy, and she looked at me. She looked at me as though she had made a terrible mistake in choosing me. She understood what I did not, which is that this is the worst way to write this code. I have this beautiful reactive API, and here I am blocking for no reason. So instead, I need to compose. I need to say, do this and then do this. And there's a nice API to do this. So I can say, delete everything, then process this publisher, which I'll provide. Well, let's go ahead and do that. Let's get rid of some of the intermediate variables here. Clean up the code just a bit, okay? There. So I'm going to take that whole thing, put it in here, and then I will say reservation repository at find all, and then I will say I'm going to print out the data. So I've deleted everything, then wrote data to the database, then returned everything, then printed it out. Now, let's see what happens. Let's go ahead and run this code as is. Okay. Now, the key thing to understand about Kotlin is that you have to remember to tell IntelliJ to treat this as a single instance only. Now, what did I do? Well, I did something wrong here. Do you see? The output, the return value of the save method is a mono of t. And so if you take this data here into a separate variable, what I actually have is I have a publisher of reservation. Because the map method accumulates the records into a publisher. So I don't want a publisher of publisher, I just want a publisher of reservation, don't I? So I need to do flat map. Okay? And if we run that code again, like so, there we are. It worked. Of course it worked. It was a demo. What were you expecting? This was always going to work. There was no question about it. Instead, what I wanted to talk to you about was this. You see, anybody who knows me knows that I care very much about this ASCII artwork. This artwork took a long time to get right. But we on the Spring team have many people who are doctors, PhDs, people who have worked in their previous lives in nuclear physics. The stars in the heavens were their bread and butter. It's what they cared about every day. So it makes me very happy to imagine that someday, somewhere, somehow, there was a GitHub issue or a Jira that says, darn it, we need good ASCII artwork. And I think you'll agree, they did a great job. Amazing. So it's for this reason that I want to take a brief moment, just a brief moment, to talk about what I consider to be a very serious deficiency or problem in the IntelliJ JetBrains product. For even though I am a fan, I think this is particularly short-sighted. See this here? See that checkbox there? That checkbox, once you click it, it says hide banner. It removes the banner from the output. That's a dumb feature. I'm not even sure why that's there, IntelliJ. Who asked you? So I did what all people would do in the same situation. I'm not a hero. You don't have to thank me. I just went on the internet and I complained loudly. And I sent a message of hope from my friend Jan Sebron. Jan Sebron is a software developer by passion at IntelliJ IDEA JetBrains. And he shared this message of hope, which I share with you here today. Don't worry, my friends. Hope springs eternal. Now, I'm waiting for this patch, but hopefully it'll come. Now, sometimes people say, oh, well, can I change this ASCII artwork? Which is a ridiculous question. You are not going to do a better job. Maybe you will. I don't know. It's possible. If you are so talented that you could do a better job, then I will show you how to do that. You just copy the appropriate file into the source main resources directory. Okay? So I'm going to copy desktop misc banner.txt here, and I'll do maven -f pom.xml spring boot :run. Now, I think we can agree that's pretty good. It's pretty good. Several things to understand about this. Meow. And then also this. Awesome. All right, so that's one way to get better ASCII artwork. You just copy a banner.txt file into the directory. The banner.txt file looks like this, right? This is ASCII color code, and you can use that if you want. Now, this is one way to do that. But one of the biggest features, one of the main features that we have introduced in Spring Boot 2.0, and maybe the most important feature ever introduced in software in history, all software, Java or otherwise, we released in Spring Boot 2.0. We're going to spend 3 hours talking about reactive, but that's not the main feature. The main feature is this. Bum 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 bum. Yeah, I don't even care if it adds like 30 seconds to the startup time. Don't even care. Worth it. Totally worth it. I expect you all to stop your production applications and update them immediately with new amazing ASCII artwork. Whatever. Anyway, moving on. Don't do that. You shouldn't stop your applications. Now, we have now amazing ASCII artwork. It is not lost on me. It's not I understand that it's ironic that the one thing that isn't reactive is the ASCII artwork. So for now, so we can save some time, I'll go ahead and remove this, okay? Now, Maven, clean. Okay. So now, we have this amazing data. We have amazing ASCII artwork. We've got data in the database. And I have done this work in this bean. This is a Spring Bean. It's annotated with that component. And it's implementing this interface. And I've done all of this. I've written all this extra code. Whoops. All this extra code just to be able to express what's in here, right? This little code right here. Now, one way to fix that, to make it a little bit less noisy, is to use Java configuration. So here, you have a method that returns an object. And I can, this is a good chance to introduce some more Kotlin syntax. So here, I'm going to create a method that injects the reservation repository. And I will return a new application runner. So I can say application runner. And then the application runner, the application runner will use the reservation repository, which I have as a parameter here. So I'll do the same thing as I did before. And now, at least if I use this syntax, I have an object, but the object is it doesn't have its own class. It's not a whole top level thing. It's a little bit cleaner. That's a little bit better. That's very Java configuration style, right? Java config since 2009. Well, of course, in Kotlin we can do this. We can make this a little bit cleaner. I can remove the return value, and since this is just an expression, I can just say that the return value is implied. The type and the return value itself are this expression on the other side of the equals method. That's a little bit better, but it's still a whole method, right? And it's still just Java config. This is maybe fine, but in Java in Spring Framework 5, we've introduced a new feature called programmatic bean registrations. And so the way this works is you add an initializer, and that initializer is called. It takes a type of application context initializer. So I could create my own. I could say application context initializer, generic application context, like so. I could do this if I wanted to. And then I could say, oh, well, I want to register a bean. So I can say it.register bean, and the bean will be of type application runner, like this. And I'll have a supplier, which provides a supplier of type application runner. And I'll provide the application runner. This is the Java style for bean registrations, right? So print line, hello, world, right? I could use the syntax, and it's a little bit nicer, I guess. The reason that you would want to do this is because you can do interesting things here. I can say if math.random is greater than 0.5, then register this bean. I'm programmatically adding Spring Beans to my application context. It's a little nicer, but this is the Java syntax. There's a Kotlin DSL. You see, one of the nice things about using Spring Framework 5 is that we have added these APIs that are only available, they're DSLs that are only available from Kotlin. If you're using Java, you will never see them. They're already in the class path, but they don't show up in your Java code. It's like a secret level in a video game. Where you find a secret level and it comes out to you and you can play. If you're using Kotlin, you get the secret level. If you're using Java, it still works, just not as fun, right? So we have a secret level here. We have this beans DSL. And here, you register bean, like so. So I'm going to say, take this, get rid of that, get rid of this, and I'll register a bean. Okay? And of course, I need a reference to that type. So here, I'll say, give me a reference to the reservation repository. So now I've got a bean. I'm registering it. I can do the same thing as before. I can say if math.random is greater than 0.5, then register this bean. I can do a for loop and create beans in a for loop or something like that. I can do weird stuff like that. I can say if the stock market is above this number, then register the bean or something like that, right? Now, same result, same exact result at runtime, right? I have beans. I have a bean here. This new functional bean definition style is one of the things that's in Spring Framework 5. Now, this DSL, you can see here, I've got a ref to a reservation repository. Notice I did not have to pass in a class literal like this. I didn't have to do that. You see, this DSL is not actually a method. It's a macro. Think about this, how this would work normally. Normally, Java Spring would need a class literal. It would use that to find the bean. In this case, I gave it a generic parameter, and it was able to figure it out automatically. That's because thanks to these macro-style functions in Kotlin, we kind of, not really, kind of have reified generics, right? And that's because basically this code gets copied and pasted by the compiler at the call site where the call is being made, where the method invocation is being made. So it's kind of a cheat. It works, but it's not a pure method. It's not actually a method that's on the dispatch table. Okay. So if you look at that, you can see it says inline reified Kotlin T. Basically, this code gets copied and pasted, and there's a class literal that's kept. It's as though I did, class equals reservation repository class. It's the same thing, right? The compiler writes that code for me and makes it available as a generic argument that I can reference in here. It becomes T, right? So I can actually say, give me t.class, All right, now, so we've got that. I got data in the database. Now I want to build a REST API, okay? So I want to build a simple REST API. I can say reservation REST controller. And I'll create a simple REST controller like so. And I'll create a get mapping endpoint / reservations. And I'll say fun reservations. And I'm going to inject the reservation repository here. Reservation repository at find all. There you are. Okay. So there's my simple Spring MVC style REST endpoint. Go ahead and restart this. Now, if I go to the browser, localhost 8080 / reservations. There's my REST endpoint. Okay. It looks fairly similar, right? This should look very simple if you've ever used Spring MVC before. The return value here is a publisher of reservation. All right? So there's that. This should look very familiar, but you must understand, this is not Spring MVC. This is a new module called Spring Web Flux. There is no servlet API on this class path. I'm using Netty. This is fully reactive and asynchronous all the way down to the IO layer, all the way back up to the web tier. There's no blocking API here. Okay? This is a different thing. This is not Tomcat. This is not Jetty. This is not Undertow or anything else like that. And think about what's happening here. Think about what Spring has to do. Spring sees, oh, you have given me a publisher of reservations. Well, it's going to take that thing, and it has to turn those records into JSON. How does it do that? We cannot sit there and wait for all the records to appear, can we? There might be 10 records, or there might be 10 trillion records, right? There may be new records as long as there is heat in the universe. There might be new records. So we cannot just wait and wait and wait and wait for the data and then take all of it and pass it to Jackson or to the DOM API for XML and then convert it. We have to do it in a streaming way. So behind the scenes, this engine is actually taking each item of type T, reservation in this case, and turning it into JSON and sending it back. We actually had to patch Jackson. We had to send pull requests to Jackson to support this. You don't have to worry about it. It just works. But everything in Spring Web Flux is asynchronous and reactive by default. Everything is a publisher. You want to use WebSockets? Create a publisher. You want to do server-send events? Use a publisher. You want to send 5 records back to the client? Use a publisher. It is the default behavior. It's not the other way around. In the servlet API, asynchronous is not the default. It's the exceptional case. It's very nice to have just one thing to think about all the time. Okay? Now, this style, I like this style, but this is also, I think this is fairly familiar. You have a class, you have annotations, you have some methods. These methods they have annotations on them. These methods are handler methods. And this is certainly, it works, of course it works. But in Spring Framework 5, we have a new style that you can also use called functional reactive endpoints. Okay? And this style is not, we are not the first, of course. We are not the first to have support for this style. You know, if you've ever used Sinatra in the Ruby world, they have this. Or Ratpack in the Groovy world. Or Scalatra in the Scala world. Or Spark Java in the Java world. Or Express.js in the Node.js world. This alternative style is very familiar to those as well. So here, we're going to create beans. I'm going to create a router. Right? And actually, you'll see that the Java API looks like this. Route. Request predicates dot get / reservations, and then you return a handler function, and the handler function must return a response, so server response dot OK, and then the body, I'll get the body by injecting the reservation repository like this, and we say that the body will be val body equals reservation repository at find all, and it'll be body. And normally you specify a class literal here, like that. That's the Java API. Okay? And of course, in Java, you can simplify this. You can say, I want to add imports, static imports, to make this code a little bit nicer. But in Kotlin, there's a much nicer API, or at least I think it's nicer, called router. Here I just say / reservations, server response.ok.body equals reservation repository at find all. So now, get rid of that. There you go. Okay? And just like before, I can say if math.random is greater than 0.5, then register this endpoint. Right? Dynamically. I can do a for loop if I want to and register dynamic endpoints based on that. So this is very different than the style that you are used to in Spring MVC. Here, you know, with this style in Spring MVC, the annotation is everything. The annotation is all of your configuration. It has to work in that annotation. If it doesn't work, then it cannot. You know, you have to go one level lower. You have to use Spring MVC handler mappers or handler adapters, right? So this is nice. You have more control over how the request is matched and what component gets used to process it, and when that handler gets registered. All this is much easier to express using this nice API. So I have now nothing else. Let's go ahead and restart that. Clean that up. Goodbye, goodbye. All right. There's the reactive REST endpoint. Okay, same thing as before. Now, let's keep in mind, this is kind of a silly example here, this right here. So let's get rid of that. And that's the entire application right here. That's my entire application so far. It's taken a while to get here. But, you know, I have reactive data access. I have a reactive web endpoint. I have ORM mapping, and so on, right? This is almost, it would be a little bit longer. I mean, maybe a few lines, a couple of lines maybe, even in Java, right? Especially if you are using Lombok. The language doesn't make the difference here now. It's just the style. It's the functional sort of style. It's much cleaner. Now, of course, I want my sample data, so we'll leave that there. Okay, so now we have an application. This application has data in the database. We have amazing ASCII artwork. Are we ready to go to production yet? Well, I'd say no, not quite. There are still concerns. There are still things that we have to care about before we can go to production. Things like observability. Observability is the insight. It's the understanding that when something goes wrong in production, we must be able to handle that failure. We must be able to see what is happening in order to support remediation or, you know, fixing the system. We have in Spring Framework, we've had for the longest time, in Spring Boot, we've had this actuator module. Actuator gives you information about the application at runtime. In order for us to use it in Spring Framework 2 and Spring Boot 2.0, we have to say, I want to include everything, and I want to show the details for everything. The actuator is not new in Spring Boot 2.0, but some parts of it are very new, and we're going to cover those in this section. Let's go ahead and restart the application. All right. So refresh, 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 refresh. And now when I go to Actuator, you can see different endpoints are here, just like before. You have the beans endpoint, which shows you all the different objects and how they're related to each other. You have the health endpoint, which shows you all the different components and their individual health, the health of the MongoDB database, the file system, etc., all that kind of stuff. You have the conditions, the configuration conditions, and how they are related. You know, what conditions are true for Spring Boot to do its work, you know, when it starts up. What conditions are true that then result in registration of new beans. You have the environment, which shows you all the different system properties. You can see the output here has changed. You have the loggers endpoint, which shows you the different system, you know, the loggers that have been configured, their levels, etc., all that stuff. You have heap dump and thread dump, which gives you heap and thread dumps. And you have HTTP trace. This is slightly different. It's been renamed. This is all the requests that were made to the application, the timestamp, the headers, the response headers, and the response time and time taken to produce the response. All that is very useful for understanding what's happening. And you have mappings. And mappings shows you all the different HTTP endpoints that your application has, right? All the different handlers, all the different content types, all that kind of stuff is here, right? So you have good information about all the different states of the applications. Now, one thing that is very different in Spring Boot 2.0 is the metrics endpoint. So here's metrics. Metrics is a place where you have keys and values, information that you can use to understand what the application is doing. These keys and values they're generated automatically for you by Spring Boot, but you can capture custom metrics. Things like how many orders do I have? How many products have been adding to the shopping cart? How many people have checked out? You know, things that you care about as a business, not just operational concerns. Now, you can use this metrics endpoint to show that data, but behind the scenes, behind this support, is a new project called Micrometer. Micrometer is a brand new project from Pivotal. We released it, we developed it specifically with the goal of integrating it with Spring Boot 2.0, but it is not only for Spring. It can work with any JVM-based project, right? It's a separate project here. Let me see, there's Micrometer if you want to take your photo. It's a separate project, and it's designed to support capturing custom metrics, right? And that metrics endpoint in Spring Boot is powered by Micrometer. It can publish your metrics to time series databases or monitoring tools, things like Prometheus and Netflix Atlas and CloudWatch and Datadog and Graphite, Ganglia, JMX, the Influx and Telegraph Tick Stack, New Relic, StatsD, SignalFX, and Wavefront. So these different time series databases all support, almost all of them, except for JMX, support dimensional data. So you see here keys and values. You can imagine a key like requests. Is that here? Yeah. Imagine you have here HTTP server requests. This shows you how many requests have been made into the application. Well, what if I want to also show how many HTTP gets I have and how many HTTP deletes I have? Well, normally in a regular time series database without dimensional data, you know, before we have dimensional data, you would have to create another metric, HTTP server requests.delete, HTTP server requests.get. And then maybe you want to show all the HTTP server requests.get endpoints, or requests rather, that resulted in a 200. So then you'd have another metric, HTTP server requests.get.200 equals, and then you'd have a number. So if you look at these numbers, if you look at these labels, these metrics are just labels for numbers, right? Here's the numbers, the count, etc. But you can see that if I have complex data, it becomes hard to change this metric label all the time. I have to add more and more data to the label itself. Well, a dimensional metrics store, like Prometheus and like Graphite, allow you to have extra metadata. So you can now do custom queries. You can say, show me all the HTTP server requests that were GET. And it'll just manage that for you. You don't have to change these. You don't have to create all sorts of new metrics. You can just add extra metadata to the existing one metric. And then you can use tools like Grafana. Grafana supports visualization of metrics. Remember, our brains are optimized for pattern recognition. Is there a tiger hiding behind the tree? Right? Our brain can see that. We're not optimized for numbers in a JSON document. If you want to understand something quickly, show yourself a picture. Visualization tools like Grafana help you with that process. You can also use these metrics to do alerting and to do automatic remediation. There's a lot of power here. They give you the ability to understand what your system is doing and then react to that change, or to that input. All right, my friends, we are at a good place for a 10-minute break. Does that work? So there is apparently coffee and stuff. So 10 minutes, okay? Come back in 10. We've been going very slow, so I want to we have a whole bunch of new stuff that we have to cover very, very quickly. Alrighty, welcome back. Okay, so we looked last time at how to build a single application using Spring Boot. We focused really on the reactive components in Spring Boot, right? These are the things that we need to understand in order to understand the rest of the journey. And I think Spring Boot itself should look fairly familiar. How many of you have used Spring Boot before? Okay, so this is the reactive stuff though. That's fairly new. How many of you have used reactive Spring Boot? Okay, so this was not. There were some of you who appreciated that. That's good. The rest of our time now will be spent talking about building distributed systems and some of the things that you need to care about when you move to this distributed systems world. And while we were on the break, I used the Spring Cloud CLI to stand up services like H2, for example. Right? There's the Spring Boot CLI, and there's a plugin for Spring Cloud, and it has support for things like Apache Kafka, Zipkin, and Eureka, and config server, all these kinds of things in H2 embedded database. So I've got a whole bunch of things running in the background here. I will introduce them, but I'm not going to bother standing up all these different pieces individually. We'll introduce them as we use them, though. So the first thing that we care about when we move to the world of building distributed systems is configuration. And I showed you how to configure the application so far earlier in Spring Boot using this property file, application.properties. Nope. So for example, I have this property file here, application.properties, in the source main resources directory. These properties are what I can use to change the default behavior of a Spring Boot application. I can specify the port, for example. Now this configuration lives in the property file, so I have to recompile the jar in order to see the updated configuration. That's not very scalable. That means that I'd have to change everything each time I want to change the application. I have to recompile the jar each time I want to change the application. So rather than do that, I instead choose to keep my configuration outside of the jar. And I could, of course, just keep it as environment variables or as -d arguments that get passed into the application when it starts up. I could do that. But instead, I choose to use a configuration server. The Spring Cloud config server is a microservice that sits in front of a directory of your configuration, a Git-based repository of configuration. The Spring Cloud config server is easy enough to build. You can go to start.spring.io and build your own config service like this, right? And then you have to specify where it's going to find its configuration, what directory full of configuration. Now the code in the Git repository that I showed you, the link I showed you earlier, has this config server, and the configuration lives here. Josh Long, beautiful reactive microservices config. All microservices will have access to different configuration properties. All microservices will have access to this one property file called application.properties. You can see here that there's a number of keys and values that all microservices will see. Only the microservice, however, only the microservice called reservation-service.properties, or reservation-service, will have access to this key and value to the keys and values in reservation service.properties. So these things are merged together. You have reservation service.properties and application.properties. And they are visible, they are accessible from the Spring Cloud config server, which I have on my local machine running on port 8888. So if I go to localhost 8888, reservation service default, you can see that it says hello Sydney, just like it says hello Sydney in this property file here. Message equals hello Sydney. So there's a microservice called the config server. Other microservices will draw their configuration from this config server, not from the property files. So we need to change our microservice to act as a client to this config server, which I have running on my local machine on port 8888. Okay, so we go back here. We need to give our microservice a name. We will call it the reservation-service. And then when you go to the build, you can see it says Spring Cloud Starter Config. All right, that's the config client. That Spring Cloud Starter Config client needs to know what the name of the microservice is, and optionally, it needs to know where to find that configuration, like this. That is the default value, though. I only show it to you because I care. I'm a giver. But I will forget for the balance of our time together, so I just need you to remember, okay? So we've given this a name, and this microservice will start up, and it'll get its configuration from the config files in that microservice. Now, I'm using an empty, sort of unconfigured, insecure config server. But you, of course, would configure the config server to support HTTP basic communication from client to config server and from config server to Git repository. Or even better, you could use certificate-based authentication. Okay? For our purposes, though, it is fine. So we're going to go ahead and create a new endpoint here. Git /message. All right, and I'm going to return a response, server response.ok.body. And the body that I'm going to return here is the body that I'm going to get from the Spring environment. So ref environment. Okay, and I'll say env. And here I would say get property message. But this is another example of where the DSL in Kotlin is a little bit nicer. You see, in Kotlin, you can overload operators, right? So I can now dereference properties in that object with a bracket syntax there. I can say message. And again, normally, I have to wrap this message. Normally in Java, you'd have to say string class, whatever. But in Kotlin, thanks to reified generics, I can just leave it like this. Okay? And once we understand that, let's go ahead and change this. Good. Much nicer. Okay? So let's see. If everything works, then we'll see the application will start on port 8000, and it will have access to this message. This is not the right message. It's the wrong city. I have not been in Sydney, Australia for several weeks. It's been 2-3 weeks almost. This is completely wrong. So I need to change this, right? But let's see if it's working. Localhost 8000 /message. Well, that's working. Okay, so that works. Now, I want to change the configuration here. cd desktop config. And here I have my directory full of configuration. I'm going to open up this property file using, yeah, it's me, Emacs. I'm that guy. All right. So I will say, bonjour tout le monde. Okay. And git commit -a -m YOLO. Okay. Now, I'm going to use the actuator endpoint here to refresh the configuration in my microservice. And I'm going to send content type application JSON. All right. So I have this configuration. You can see the config server. It sees the updated value here. Right? It's correct. But here, nothing has changed. So I want to change that configuration. I'm going to send an empty HTTP post to the microservice. Go. Okay? As soon as I hit enter, it triggered a refresh event. The event redrew the configuration from the config server. This supports things like feature flags, right? I can decouple the deployment of software from the release of that software. And also, I can also create event listeners, right? I can create a bean that listens for an event that I can then respond to. So I guess what's the easiest way to demonstrate this? I could show you a bean up here. Event listener, refresh, scope, refreshed event, class, fun, refreshed. Okay. Print line, new property has been changed. Okay, so that's my event listener. If I restart the application, and now I make another call just to do that, you can see that it shows down here, property has been changed. So whenever that event is called, this callback listener is there. So if you want to change your state, if you want to reconfigure variables or whatever, you can use that as a listener, as a chance to reconfigure and to get the new configuration. Now, I can also annotate my beans. I can actually create beans that are annotated with @ refresh scope. So I can say class refreshable bean @component, and I can say I want to inject the val message string @value. Now, it's weird because this is a little bit of a problem. You see, in Kotlin, this syntax here is actually a language feature. Kotlin will replace those variables. So you have to escape that here. So I'm escaping it. Now, I'm going to create a bean there, and well, I guess I'm not doing anything in particular, but I want this bean to be recreated whenever there is a update. So whenever that message is updated, I want to be able to recreate the bean here. That's what this annotation does. I can now inject this bean into anything else, for example. Let's see if I go here. And so I could say, give me the pointer to the val refreshable bean equals refreshable bean. All right? And I could say, instead of env, I could say refreshable bean dot message. Right? Let's try that. So we have this endpoint. There's the old value, yeah? Go here, Emacs reservation service.properties. Well, do we want to change it? Yeah, I guess we could say, Demox France, okay. Good, git commit -a -m, YOLO, git status, nothing, good. Okay, so that's changed. Now, you can see that in this case, I'm injecting the refreshable bean, and that bean has injected the value in the constructor. So I'm dereferencing the updated bean. That's very convenient. So you have a number of different ways to respond to property source changes, okay? Now, the next thing that I care about in a distributed system is making it easy for one service to find and work with another service. And so for this, we use a service registry. In a dynamic cloud-based environment, services will come and go based on demand and capacity. So we want to make it as easy as possible for these services to find and work with each other. We could use DNS, but in a dynamic environment, DNS has a few limitations. First of all, DNS is a very simple protocol. It'll tell you where something lives, but that's not the same question as knowing if that thing lives. So you might know that I live in San Francisco. And if you are ever in San Francisco, say hi. But knowing that I live in San Francisco is not the same as knowing, well, if I live, right? I might be, dead on the floor, right? It's a very morbid distinction, but the distinction is important here. If you have a service, knowing its IP address is not the same as knowing if that service is alive and will respond. You need to be able to decouple the location of that thing from its availability. And a service registry gives us a logical way to do that. A service registry is like a phone book. It contains a listing of all the different services and their IP addresses. And there are many different service registries. I have, on my local machine, Netflix Eureka. It's running on my local machine. Now, you can use any service registry you can imagine. You can use Apache Zookeeper, HashiCorp Console, Netflix Eureka, Cloud Foundry, Kubernetes. They all have implementations of the discovery client Spring Cloud abstraction for service registration and discovery. I have this running on my local machine, and I'm going to teach my microservice here. I'll tell it to act as a client to that microservice. So I'll add this here, to the service registry rather. I'll add the Spring Cloud discovery client abstraction implementation. There's a few things that we should understand. I just restarted this, by the way. This should have restarted right now. There's a few things we should understand about this, the service registry. First of all, very well done mouse over. That took a year. And also, at the second, well, I haven't refreshed the page, but before, there are no instances of the application registered. Now, if I refresh, we see that in the last, 30 seconds or whatever, that application is registered in the registry. And it's at this IP address, this service ID, and this port. It is advertising its presence for others to consume. So now let's build a client that talks to that service registry to find the service instance, and then is able to use it to do interesting things. So we're going to go back here. We're going to build another Kotlin-based application. We're going to use the Reactive Spring Cloud Gateway project. We'll use the Reactive Redis support. We'll use the Spring Security support, the Reactive Web support. We're going to use the Hystrix Circuit Breaker, Zipkin for distributed tracing, Kafka for messaging, Reactive Spring Cloud Stream. What else do I want? Is that enough? Could that be enough? Should it be enough? Kafka, Eureka, config. Anything else? Sorry? Ribbon. Oh, good point. That's already, yes, I do need that, but it's already there. It's going to be there because of gateway. Thank you. He's right. I needed ribbon. Let's see what else. I think that's probably enough. Probably enough. Whatever. We can add it later. My mind is like a steel trap. Where am I? Oh. So anyway, we're going to hit generate. And we'll have a new project and download UAO reservation client.zip. All right? Now, this client is a edge service. It's not just a client for the sake of building a client. It's a thing that will act as the first request, is the first entry, is the first door through which messages coming in from the outside have to pass. So we're going to give it a name, Spring Application Name equals reservation client, and we'll go ahead and get rid of some of the dependencies that we don't need just yet. So we will remove, for example, the Zipkin, Kafka, reactive support. Yeah, that's it. Okay, so that's going to be gone for now. Now this edge service is our first port of call, and again, we're building an edge service. It's a thing that we can use to handle client-specific requests. When I say client, I mean things like your iPhone, your PlayStation, your Xbox, your Roku, your HTTP browsers, your HTML browsers. All these clients. Each client has its own specific payload and protocol requirements. So rather than change every single microservice just because you have added a new client, we instead allow requests to go through this edge service, and we adapt the requests to the downstream service. This is a great place to apply any cross-cutting concerns, things that apply to all services in a generic way, things that you can do generically across a number of different services. And so here, we can use, for example, the new Spring Cloud Gateway project. Now, one example of this use case is we have an HTML5 browser application. HTML5 browser applications live in a secure sandbox. The sandbox makes it makes it impossible for them to make requests to other hosts and ports on different nodes without adding access control origin header information to the downstream service. We can get around this by proxying the data. So we're going to use Spring Cloud Gateway to do that. Okay, so I'll create a bean here. Actually, I can do it this way. Add initializers, beans. Okay, there's that. And I'm going to create a bean here. And we are going to create a bean using Spring Cloud Gateway. Now, Spring Cloud Gateway is a generic framework for processing requests that we're going to proxy through the edge service to the downstream services. So we need to get access to a pointer to the route locator builder. And we're going to define a bean of type route locator, right? Like this, route locator equals RLB dot routes dot route. And the Java API looks like this. In the Java API, you create a route spec, and you say route spec dot, and you define the how the request that arrives at the gateway is matched. So we're going to say, oh, I want to match all requests going to dot gw.sc, okay, on this host, and I want to match anything going to this path proxy. So, you know, things that you would do with mod rewrite or nginx or these kinds of things, you can do here. And then, once I've matched that request, I want to specify a URL. So, spring.io:/guides, right? Now, I could filter this data here. So, filter spec, like this, fspec, and I could add all sorts of interesting filters here, and we'll come back to this in a second, but for now, let's just look at a very simple example, okay? Now, I'll restart this application. Single instance only. So the application's up and running. Now, I'm going to make a request here. Keep in mind, if I look at my etc hosts, it says I've got foo.gw.sc and bar.gw.sc. So I'm going to make a request to those hosts on my local machine. Curl, HTTP, localhost. I'm going to use the host header. That's the one that matters here. Because if you have a F5 or something, it'll transmit a host header. So I'm going to make a call to proxy -h host. And then the host would be foo.gw.sc. And we made a request to proxy, right? So what did I do wrong? gw.sc -h. Sorry? Did I do something? gw.sc. I don't think I need the content type for the read, do I? Content type, application, JSON. No. Wait, cat etc hosts. foo.gw.sc. Looks correct. Curl localhost 9999 application.properties. Oh, it's because I have security. Let me disable the security for a moment. There we go. My goodness. My system is so secure, I locked myself out. There we are. Oh, and also, I have not returned a value, so that wouldn't work either. So, well, actually, it should work. Let's just see. Whatever. Yeah, should be fine. All right. So there you go. As I make these requests, you can see the HTML coming from the different guides at spring.io/guides. Okay? So it's a very simple proxy. And this is reactive only. This doesn't work in the this needs the Reactor and Spring Cloud and Spring Web Flux. It needs the reactive support. Because think about it. You're going to make a request to another service. You don't know what's on the other side of that service. Might be just a few kilobytes of JSON. Might be terabytes of JSON. You know, who knows? So you want to stream through the data as it arrives. You know, so this is using a reactive web client. Now, this is a very simple example, and it's not particularly useful, but it does demonstrate how this comes together. Now, before we go too much further, I'm going to refactor this and take advantage of a DSL in Kotlin to make using Spring Cloud Gateway a little bit nicer. All right. So here, I'll say rlb.routes using this bit right here, and then route, and I'll say host is going to be equal to *.gw.sc, and path is equal to proxy. The URL will be equal to this as well. Guides. All right. I think we can agree. It's nicer. Don't need to specify build, it just works. Okay, so now that's the same thing, and actually we can, at this point, clean that up a little bit even more. There we are. So now, let's make sure that works just like before. And by the way, you can specify custom predicates, right? So I can do any kind of custom predicate I want. I can say, oh, well, and where's my spec? Well, this thing right here, this is called a Boolean spec. So I guess Boolean spec. Yeah, you can provide your own custom matcher. Is normally the way that works. Let me try this again. .routes. In Java, it looks like this. You have a route rs dot predicate. So it's a predicate. Usually, you provide a predicate of something, and then that predicate is what actually matches the request. It's a little bit different in the Kotlin DSL, but you can provide your own custom predicates, is my point, and you can describe anything. You can say, oh, well, if the market is above a certain threshold, or if Mercury is in retrograde or whatever, you can match the incoming requests, okay? So I'm using the DSL here to say match the current host and the path, but there's other ones like, for example, if there's a header present or whatever, if there's a cookie or if it's a certain date or whatever, you can do all sorts of very complex matching there. Now, I'm going to use a filter to process this data. A very simple filter is to set the path manually. So I can actually remove the path from that URL and just use this. And this will work as well. So, okay, so that's the Kotlin version using a custom filter. Now this is a very simple example. What about if I wanted to make a request to my microservice, my reservation service in the service registry? In this case, I would say lb:/reservation-service/reservations. Reservations is the path here. So now, my friend in the front here already explained or basically hinted at what this is. This is ribbon, right? Ribbon is being used to extract the host from the URL, go to the service registry, get all the different service instances, and then pick one to make the request to. There is no DNS server here. Okay. Now that is a load balanced request, and the load balancing algorithm by default is LRU, least recently used. But you can do all sorts of other custom load balancers. You could do data center aware load balancing. You could do multi-tenancy. You could do, whatever you want based on data center awareness, multi-tenancy, round robin. I mean, whatever strategy you want to plug in there, you can. It's just an object. It's just a bean. So we have a load balanced call. Let's see what happens there. found reservation service does that make a difference? Do I have a reservation service? Localhost 8761. I've got a reservation service. It looks like it should be fine. So now, if we go to this console, no, okay, what's going on? Do I not have Eureka? I do have Eureka. Located environment reservation client. Eureka client, load balance colon reservation service, reservations, localhost 8000. Okay, there's something wrong with my service. What did I do? In my code here, at some point, I brought in Tomcat, which is breaking my REST API. So you need the Eureka client, not the Eureka server, in your reservation service. That explains everything. Come on. There we go. So now, if I go back to my console, everything's fine again. Okay? So I've load balanced my request across this. I've made a request to the downstream data. I got the JSON back. It's a load balance request from the edge service to the downstream service. Now, this is a very simple filter, a very, very simple filter. All I'm doing is I'm setting the path. But as you see, there are so many useful filters besides this. A very common one, very common ones are, for example, you can add request headers, request parameters. You can set headers. You can do retries. You can do circuit breakers. You can do rewriting of paths. You can do all sorts of things here in the filter. One of the common things that people ask about is how can I do a rate limiter, right? A rate limiter is a way to protect the service downstream. I want to make requests to the downstream service, and if there's too much traffic, I want to stop the requests. Well, in theory, this is a very simple job. I just have a number, a quota, and I keep a count of how many requests I have allowed to go through, and as soon as that number exceeds my quota, or if it's more than my quota, I reject the requests. Well, where do I keep that number? Where do I keep that count? If I keep it in the Java code, it's not going to work very well, is it? Because if I have one instance of this edge service, and I say, okay, let's say I want to only allow 5 requests per second, okay? Maybe you have some very slow service using PHP, and it falls over very quickly, If I have only 5 requests per second, then as long as I've got this code compiled and it says, integer count equals 5, it's going to be okay. But as soon as I scale up, as soon as I have 2 instances of the edge service, well, now I have to keep this number somewhere else. Otherwise, I'm now in actuality letting 10 requests go through, aren't I? Even though I only want to allow 5. So I need to keep that count somewhere. I can keep that count elsewhere. Redis, exactly. So I'm going to create a request rate limiter. I'll provide some config here. And the config requires a few things. It needs the rate limiter itself. And the rate limiter strategy I'm going to use, the rate limiter implementation, is Redis rate limiter. And I'm going to specify that I accept 5 requests and I can burst to 7. And I'll inject that reference here. Val rl equals ref Redis rate limiter. Okay. And actually, I could have just said ref like that, and that would have just been inferred by the compiler. Okay, so there's that. And by the way, this config, I could just say it. All right. And get rid of that. Get rid of that. Okay, so now, is that enough? And by the way, this also could be a property. All right, is that enough? That's a good start, but think about it. Redis is a key value store. It's a distributed data structure server. All the different types that you can store in it are accessible by a key. So it's going to look for a key, and then it's going to have an atomic number, an atomic integer, basically, a counter that's going to increment for us, and it's going to be visible and consistent from all the different threads. Well, I've got a single, right now I've got a rate limiter based on Redis, but how is that key being arrived at? Where's the configuration for that? Well, the strategy is provided by the key resolver. And the key resolver is of type key resolver. So I can say key resolver. And here, I could just say, the string is equal to my counter, right? So the contract here for this is to return a mono of string resolve. So I could say mono dot just my counter. And that's the contract. That would be a very simple implementation. So what that means is it's going to go to Redis. It'll go to Redis, and it'll look up an instance of, it'll find this key in the Redis registry, in the Redis database, and then it's going to use the number to figure out whether we've already exceeded our allotment, our budget. This is a static number, and it's going to be the same number for every request from anybody. But maybe I want to be more dynamic. Maybe I want to say, oh, well, I want to only allow 5 requests for each user, for each authenticated user. Okay, and that's the default strategy. So usually, I would just use this, right? That's the default strategy. But this is what's going to be used as a principal key name resolver. So I'm not going to configure it because that is the default one. But we still need to configure Spring security, right? We can't have an authenticated user without Spring security. So now we need to use Spring security to configure, authentication and authorization. Authentication and authorization, in theory, are very simple. For every request that enters the application, we want to have some sort of mechanism to say, is this a valid user? That's called authentication. Who is this user? Is that user who she or he says she or he is? Okay, so we can do that using, for example, a reactive map user detail service. So in order to use Spring security, I need to bring in the Spring security support here, like so. And I'm going to say map reactive user detail service. Okay, and here I'm going to provide a hard-coded username or a hard-coded user with a default password encoder. And I'll provide a username equals user, sure. Password equals password. It's always password. Why do users do this? And then roles will be just user, all right? Rob Winch would disapprove. Rob Winch is the lead of Spring Security. Don't tell him I did this. Just password. Oh, I can feel him being upset right now. I'm sure he is sneezing. All right, so there is a reactive authentication mechanism. Now think about what happens. This is going to be used by a filter. Spring Security will install a filter that will then intercept any incoming requests, and it'll check the incoming request somehow for information that it can use to confirm that this request is coming from Jane or Josh or Joe or whatever, right? Different people. In this case, user. Well, that information might be, for example, HTTP basic headers. These HTTP basic headers are coming in from the client. Well, that's a filter. And then once that filter is done, it's going to set that information. It's going to put the authenticated principal, it's going to put it somewhere so that code downstream, after the filter, can get access to it. Other filters and your your controllers, right? Well, historically or traditionally, that place is a thread local. Well, thread local doesn't make a lot of sense here, right? There's no guarantee that the thread that is used to process the request is the same thread that will produce the response. We cannot use a thread local here. So Reactor, Project Reactor, the reactive runtime we're using, supports this object called a context. Every publisher from Reactor, a Flux or a Mono, has a context object. It's a dictionary. It's a key value context. and it'll perpetuate, or it'll keep the key value data associated with the publisher in the pipeline. And by the way, it's very important to keep in mind, like I said, this is all asynchronous. So going back to the reservation service here, I should mention that this is asynchronous. It's happening. It could happen on different threads. You can control the threads, right? I could say I want to use this, or from executor, or whatever, right? So it's important to understand these are happening on different threads. That's why it's important that we cannot use a thread local. Now, going back to here, Spring Security is going to use that context object to make sure that all downstream code can get access to this authenticated object. Now, I also want to have authorization. Authorization is how you tell Spring Security who can and cannot access what resources, what endpoints are visible. So here, I'm going to use a server web filter chain to configure that. In order for me to do that, I'm going to need a pointer to the server security. So security builder, let's say, equals ref server HTTP security. And I'll say builder dot CRSF dot disable and HTTP basic and authorize exchange. And I'm going to specify that any request I'll allow except for the requests going to proxy, which have to be authenticated. And that's it. Now I'm going to indent this a little bit. I'll say @formatter off and turn that on. All right. So there we go. There's the authorization using Spring Security here, right? Spring Security 5, reactive Spring Security. Now, let's try this out. Curl minus, well, first of all, that should not work. Good. Minus V. Let's get rid of this. And you can see when I make that request, it says 401 unauthorized. That's as we expect. Okay. Now, we can try minus U, user password. Okay, so there's the JSON data. When I sent the HTTP basic username and password, I got the response back down there. I can pass it to JQ and get the data. Okay, so that's working. Now let's try the rate limiter. So here I will drive a simple bash script to drive some traffic. All right. So now you can see it says 429 too many requests. I'm rejecting, for any authenticated user, I'm only allowing 5 requests per second. Anything more than that, and I reject it. So 429, JSON. 429, JSON, 429. Okay? So that's a very simple rate limiter using Spring Cloud Gateway. Now, this is a very simple example. I'm using the rate limiter. I'm using Spring Cloud Gateway to create different routes, and I've got this nice DSL in Kotlin, and it is great for cross-cutting generic concerns. But sometimes I want to have a custom endpoint that is it reflects, it's a customization. It's a synthesis of data coming from other services. Maybe I want to have a new endpoint called Service C that takes the data from Service A and Service B and merges them together and then processes them and so on. And so in this case, I cannot just use Spring Cloud Gateway. I need to use something, I need to create my own custom endpoints. And we can do this using yet another route. So let's just create another route here. Okay, so we say bean router, and here I'm going to create an HTTP endpoint /reservations /names. And the reservations names endpoint is an endpoint that's going to return the JSON that we have from this endpoint, from our reservations downstream endpoint, but only the names, not the IDs or anything else. So in order to do this, I need to use a reactive web client. So I'm going to create a bean of type web client. This is like the REST template. but it's reactive. The REST template is a 10-year-old API. It's worked well, but it doesn't do a great job for reactive, consumption of data. So this is a natively reactive web client. And you can use it for things like server-sent events, for example, right? Now, this web client does not know about Ribbon. It doesn't know about Eureka. In order for that to work, we have to use the ref. We need to use the load balancer exchange filter function. Val EFF. Rolls right off the tongue, right? Simple. So I'm going to say dot filter EFF. So I'm building a reactive web client. I'm configuring a filter that will process the requests, go to Eureka, do load balancing, and then send the request to the downstream service, all in a reactive way. Now let's build this endpoint. I'm going to say inject, val client equals ref web client. All right. And now I'm going to say client dot get dot URI equals HTTP / reservation service / reservations. I'm going to retrieve the data, and I'm going to turn the data into a payload of type reservation. Well, of course, I don't have this type in the class path, so I'm going to do something terrible, something that you should never ever do, not even when you're all by yourself, all alone at home, and no one is looking. I'm going to copy and paste some code. Okay. Good. Now, I have taken this data, I've mapped it into a publisher of reservations, and that's what I have, by the way, so far, right, is a publisher of reservations here. And if I say dot publisher of reservation, that works, right? That's what I have so far. But of course, that's not enough. What I really want is, whoops, there you go, dot map it dot reservation name. And that gives me a publisher of names. So val names equals publisher of string equals this. All right. Now, is that enough? Well, I have to return a server response. So I say server response dot OK dot body, and the names will be the body. Okay. So that's my response there is just that reactive stream of data there. Okay, so now, if I go to my client here, curl HTTP localhost 9999 / reservations / names. All right, there's the names as we expect. So that's working. We're getting the names back. But I'm ignoring a very real problem with this code, aren't I? I'm ignoring a real problem with this code. Right now, I'm assuming that this will always work. I say, oh, well, as long as there is one or more instance of this service in the registry, everything will be just fine. But this ignores a very real problem. What happens if I have 0 instances of the service in the service registry? If I have no instances in the registry, it's going to break, isn't it? It's going to blow chunks. I need to do better. High-performing organizations understand that at some scale, eventually, things will always break. There's always something broken at a sufficient scale. In this case, I'm assuming that I will always have one service available at least, but that's not always true. And if I leave this code like this, it'll blow up in somebody's iPhone or Android experience. They'll get a terrible experience because we didn't care about this corner case. And what this code is going to do is it's going to try and load balance across 0 instances. Well, can you load balance across 0 instances? That's like dividing by 0, right? Do you know what 0 divided by 0 is? Hey Siri, what is 0 divided by 0?
Imagine that you have 0 cookies and you split them evenly among 0 friends. How many cookies does each person get? C. It doesn't make sense. And Cookie Monster is sad that there are no cookies. And you are sad that you have no friends.
It's true. Don't make Cookie Monster sad. We need to understand that at sufficient scale, something will go wrong. Not a matter of if, it's a matter of when. We need to write our code accordingly. In this case, we can fix this by using a circuit breaker. So I'm going to adapt this code to use a reactive circuit breaker. I'll say val circuit breaker, circuit breaker, there you go, equals hystrix commands dot from names, eager, command name equals names, for example. And I'm going to provide a fallback behavior. I'll say, when something goes wrong, call this fallback. And then I'll build it. And then that is what I'll provide into the body here. So I'm adapting the names circuit breaker. And this is, by the way, also a publisher of string for all intents and purposes. Okay. All right. Here. So that's fine, no problem, right? Everything's fine. Now, I go kill the poor reservation service. Goodbye. Get that cached, and it says eek, right? So eek is the fallback behavior. What we did not get is a big, fat Java stack trace. We didn't get a 500 error. We got a regular degraded behavior. High-performing websites will do this all the time. They say, oh, well, you went to the search engine for whatever, and it's not available right now. Here are some machine-learned recommendations from across the web. Is it what you wanted? No, of course not. But it's better than nothing, right? It's a degraded behavior. This is great for read. What about write? What if I write data to the downstream service? Right? If I write data to the downstream service, I can't use that web client anymore. What if there's nothing there? What if there's no service to take the data? What if I send the data to the downstream service using the web client and there is no service? I'm going to make a post, and the post will take the data and just drop it on the floor. What else can it do? There's no place for the data to go. It's going to lose my data. This isn't MongoDB. We can't just lose data for no reason. We have to do better. Even a little child knows if you take something that doesn't belong to you and then run away with it, people are not happy. Mongo. So we need to do better. One way to fix that is to use eventual consistency, right? We can use eventual consistency. We can say, I'm going to write data to a message queue like Apache Kafka or RabbitMQ or something like this, and then have that broker deliver the message to the downstream consumer when possible. And we can do this very easily using Spring Cloud Stream here. In order for us to use Spring Cloud Stream, I'm going to bring in the dependencies back on the class path here. I'll just bring in everything. And Spring Cloud Stream requires a choice of binder. Here, I have made the selection to use Apache Kafka. So in order for us to use Spring Cloud Stream, I have to provide a binding definition. So I'm going to say, this is the service. Let's go to the other one, the client, and add these dependencies as well. All right. So now here, I create a binding, and the binding is an interface usually. So producer channels, and you say I have an output channel, fun output equals message channel. And I could call this output. And that binding definition, I pass here. Producer channels. All right? That's what you would normally do. But of course, this is, this name here is up to us. It's what we can name it. We can name it whatever we want. So products, and another one called at output, fun orders, message channel, etc. You can change this however you want. But I only have one downstream service, and this is a common thing. So Spring Cloud Stream provides its own interface called source. And source has exactly the same thing, output channel, message channel, output, with a string equal to output. It's very common, so we just provide a default one. You can have your own. If you have multiple destinations, then you can use your own interface. But in this case, we can just use this. So now with that in place, I can create a new endpoint here. I can say post reservations. And here, I'm going to take the incoming request, right? I have a incoming request. I'm going to take that request, take the body and turn it into a publisher of type flux reservation. All right. Come on. And I'm going to take that data and I'll map it to reservation name. And I want to send that data on the channel, on the output channel. So I'll say val output equals ref source. This is the interface name dot output. Right? So I'm injecting the channel definition here. And actually I can val source equals this. There we go. So I'm going to now use that in this code. Actually, I can just get rid of this. Map dot, and I'll map the RN to a message with payload it.build. And then the result of that, I'll map to a send on this. So I'm going to send the message to my downstream thing. Now, of course, this is not a response sent. This is actually publisher of Boolean. And I need to send that publisher of Boolean down to my client, my post client. What is the issue here? Oh, yeah. So return server response dot OK dot body equals sent. That was right the first time. Okay. And what is the problem here? Oh. Now this is an interesting thing in Kotlin. Here I'm telling Kotlin this variable is typed as being nullable. The string is nullable. From the string from here, remember I declared it as val reservation name string question mark. But I need to tell this API, I need to say, look, I know it could be null, but just ignore that. Just do it anyway. You're yelling at the compiler. You know how you sometimes yell at the compiler anyway? Well, now you have an official reason to. That's nice. Now, you could do this. The other thing you could do is what they do in Groovy. They have something called the Elvis operator. And the Elvis, Elvis, the singer from the States, you could say, and then in this case, I could just return empty code or something. That's the Elvis operator. Do you know who Elvis is? It looks like his hair sideways. Never mind. It's okay. So basically, this syntax says, use this if it's not null. If it's not null. If it is null, then use this value. Whatever. Right? I prefer to yell at my compiler, though. So there we go. Okay? There's my post. Now, on the consumer, on the other side, I need to do the same thing in reverse. So I'll say @enable binding sync. And sync is the Spring Cloud Stream interface. And here, I will create a message. I'll create a stream listener that listens to incoming data. Fun incoming. And I'm going to use the new reactive Spring Cloud Stream support. So I'm going to say sync.input. I'm going to ask it for incoming. It's going to be a publisher of strings. So think about it. Every time a message arrives from Apache Kafka, this publisher will emit a new item, and I can then subscribe to it. So I'm going to write data to the database. I'll say val reservation repository. I'll say incoming dot map it. I'm going to turn that each name. I'm going to turn it into a new reservation equals it, and then I'll write that data to the database. I'll say reservation repository it, and this I'm going to flat map, and then I'll say I'm going to subscribe to the whole thing. Saved it.id with name it.reservation name. Okay. So that's the consumer side. I'm just taking the data in from the producer. Restart. All right, now let's go ahead and send some data to the Edge service via a post. Application JSON. And we'll say, quote, quote, reservation name. I'm going to send a few of my favorite doctors to the endpoint here. Okay, so curl empty, we're going to send a JSON document containing reservation name, Dr. Sire, content type is equal to application JSON. Dr. Sire is the co-founder of Spring Boot and Spring Cloud. He's one of my favorite doctors. Magic V, whoa, what is Magic V1? What did I do there? That's the most direct mistake, error I've ever seen. Okay, hold on a second. We are. Is it? Oh, thank you. Yeah, it should be. It should be D. It's minus D, but yeah, just in case. No. Let me see. Reservations. 99.99 reservations. Content type application JSON. Reservations. It, in this case, is a message of string. Wait, why is it a message of oh yeah, it's a message of string. Okay, that makes sense. That's this. Reservations. Reservation client. What did I miss that's obvious here? Did I forget to restart it? Orgs. I think I know what it is. And I'm not sure if we have enough time. Let's see. Apache Kafka. I used a new Kafka and I regret that. Downloads. Download. It's probably fine. Whew. Okay, whoever's torrenting, please stop. 9 seconds left. That's incredible. Wow. Nice job. That's amazing. Okay, so extract, close, and we go to this, and I've got Kafka running here. Just goodbye to this, and we're going to go downloads, CD, desktop, Apache Kafka, downloads, CD Kafka. All right, so bin, Zookeeper, server start. Oh no. Well, we don't have time to fix this right now. I'm going to change this to RabbitMQ, and I won't feel bad about it. Okay, there's this. We don't need this. P. Oh yeah, thank you. Although I don't think that even matters. Shouldn't matter. So let's restart it. That's the client. And the service will be RabbitMQ. Kafka client, come on. Rabbit. Good. Okay. All right, that's up and running. Let's try it out again. There we go. So on the consumer side, it says saved this ID with name Dr. Sire. Okay. Now if I try again, Dr. Strange, another one, and there's that. Right. So that's working down there. Now I want to go ahead and kill the downstream service. I kill the reservation service. Goodbye to the reservation service. And I send another post, and I'll say Dr. Pollock, Dr. Seuss. Okay, now as I restart the application, it's going to drain the configuration and reprocess it. Okay. Good. So there's this. Now that's up and running, and you can see that as it started up, it took the names Dr. Pollock and Dr. Seuss and processed them retroactively. So it did that despite the fact that it was down when I sent those messages. And this is all thanks to Spring Cloud Stream and some very convenient configuration that you can see in the config server. So now, let me see, 9411, let me see if that would be worth doing. Nah, we'll come back to it. So now we have, we've looked at how to build an application. We've looked at how to build microservices using Spring Boot and Spring Cloud, and we've talked about a number of different use cases here. And we've done so using the reactive theme, throughout it all. And there's a lot more we could talk about in terms of observability, but in this last 15 minutes, I want to talk about a different kind of workload. In this case, I've been talking to you about things that require a little bit of state. They are long-lived. They start processing data. And they are in constant use, and so it's worthwhile to keep this thing running. But there is a lot of things that we've had to care about in this case, right? We get more control by using Spring Boot and Spring Cloud to create these microservices. But we also have to worry about more things. We have to care about scaling up the application. Hopefully, you have something like Cloud Foundry, which will scale it up for you. But you have to manage that. We have to care about the URL schema, the structure of the URLs. We have to care about routing requests to our business logic and then taking the data that comes out of that and turning it back into a response for the client. All of that is stuff that we have to care about. Same thing for security, same thing for all this other stuff. But there's a lot of use cases, a lot of things out there that they're just sort of work, I just want to be able to throw the work out there and have something process it. And we used to talk about back office systems. We used to talk about functionality that lives in the background that you communicated with in terms of messages, in terms of message queues, middleware, right? And that use case is still there. And we also used to talk about tuple spaces, this idea of a cluster of handlers that can process data. Well, what is old is also new. So these days we talk about functions as a service. Like we've heard of function as a service platforms like AWS Lambda or Google Cloud Functions or Azure Functions. These are all basically the same idea. And there are even open source function as a service platform offerings as well. We have one at Pivotal called Project Riff. Project Riff. Project Riff, R-I-F-F, stands for Riff is for functions, which 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 stands for Riff is for functions. Yeah, it's a recursive acronym. What can we do? So anyway, it runs on top. It's open source. You can run it in your own data center. You can run it on anything that supports Kubernetes. It's based on Kubernetes, and it in turn is polyglot. It manages functions for any number of different languages, including Go and Node.js and Python and Java, of course. So what I'm going to do is I'm going to create a very simple function just to demonstrate in the time we have left together how you would do that. Now we're going to use a new project called Spring Cloud Function. Spring Cloud Function lets you write your function once and then deploy that function to a number of different serverless function as a service platforms, including AWS Lambda, including Google Cloud functions, including Microsoft Azure. But we're going to use Project Riff because this is open source. You can run it in your local machine, and it's also the easiest way to deploy a function. It takes a crazy amount of configuration to deploy anything into AWS Lambda, for example. Configuration I don't want to do, and I certainly don't want to have to drag and drop, functions jars into a file upload form and so on. So I'm going to go to my initializer here, start.spring.io. We're going to build a very simple example, and again, I don't have a demo here related to the reservations. You can imagine maybe there's a function that sends emails when somebody registers in the database or whatever. When we have a new registration for a reservation, we could have a call to this function, and that could then send an email. That function as a service platform will either have an instance of the function running, in which case the function will handle the work, or the function as a service platform will queue the work, and it'll start up an instance of the function. If there are already functions running, but there's not enough capacity to handle the requests, the function as a service platform will scale up. It'll add as many functions as possible to handle the requests, and then it'll scale down to 0. Right? It does that all automatically for you. So we're going to use Lombok here. I'll do a Java project here, and we'll create a simple function. Now behind the scenes, I need to also add the Spring Cloud Function dependencies, right, to make this work. So we're going to use the simplest Spring Cloud Function dependency possible. I'll say dependency management, dependencies, dependency, Spring Cloud Function dependencies, and I'll bring in the Spring Cloud Function Web dependency, the specific one. Cloud Function Web. All right. So there we are. That's going to be managed by this dependency management section down here. Oh, whoops. Scope import type equals POM. All right. So this dependency is managed for us by this one. And that allows me to write a very simple function using just regular old Spring Boot. Okay. So I'll say @bean function. This is a Java util function. And the function has inputs and outputs. So I'll define a publisher. I'll define an input type called input and an output type called output. I'll use Lombok here to make this a little less tedious, like so. And we'll have a string here, private string value. And voila. Okay, that's our simple payloads. Or you could just use strings or numbers or whatever, but I want to demonstrate how to use complex types. Okay, so flux input, flux output. And we're going to call this function uppercase. And our job is just to return a new function definition. Very, very simple, even simpler in Kotlin. So I'm going to say, when the input flux comes in, I want to map each input into a new output that has a value that's uppercased. And of course, this could be rewritten as lambda. There we are. And that's the whole application. Okay? So I'm going to go ahead and compile this code. CD uppercase, Maven clean install, drink some water. And I have Project Riff running in the background. If I use Riff list, it says I have nothing deployed into Riff. I have the Riff CLI, Riff RIFF, and I've got no functions existing. So now I'm going to deploy this jar. I'm going to say history grep riff create. All right. Let's try this one. So I'm going to use this convenient command here, and we'll walk through it by hand. So I'm going to use this shell script here, and that shell script, well, let me go ahead and do that first of all. And we'll look at what the shell script did. The shell script ran this command. It says riff create Java using this artifact called uppercase.jar, which is, I have this artifact. Right? And then create a Kafka topic called up that accepts incoming requests. Anything that's on that topic gets delivered to the function. If there's no instance of the function running, Project Riff will start an instance of it. We gave the function a name called up, and we told the Project Riff runtime that the handler is the uppercase function in the main class called com example uppercase application. We also told it to use the Java function invoker version 006 snapshot. All right. So that's the whole command, but I use that little shell script to wrap it. Now, when I run this, let me kill this here. Okay. When I run this command, you can see it created up function.yaml and up topics.yaml. These are Kubernetes objects. There's a Kubernetes function object now and a Kubernetes topic. These are for Kafka behind the scenes. But it could, in theory, be other brokers. And we also have a Docker file. So this Docker file demonstrates the sum total, the whole definition here. It says use the Java function invoker base image, use this function jar called functions uppercase 00 snapshot jar, and this handler, and add this artifact to the container, and then create this function, this environment variable that points to the function URI. That's all used by Project Riff. Now, when we do Riff list, we can see that there's a function that exists there called up. So now, if I want to send a request, I can say Riff publish input equals up minus D is going to be called value. Bonjour. Devox France. Minus content type. Application JSON. And we're going to ask for a response to come back. So I could send a request and not get a response. It's just fire and forget. But I'm going to set up a correlated listener for the response here, okay? So it's posting to the endpoint, to the Riff gateway, requests up. And there's a response, okay? So that happens, that was slow the first time, but everything after that is fast because the function is warm. But if I let the function just not do anything for a second, it'll go cold. And then I have to wait for the container to boot up again, the whole Spring Boot application, right? Now in this case, I specified an input topic. Input equals up. I could also specify an output topic. Reverse, for example. And if I have another function that has input equals reverse, then this value will be sent to that function, and then I will get the response from the second function. I can chain them together, right? I can compose them and do interesting things with them. Okay? Whew. Well, my friends, it's a wonderful, wacky, reactive world out there. We've only gotten to cover just a little bit this time. Just a little. I wish we had more time to cover just a little bit more, but I'm afraid, my friends, we're all out of time. We're all out of time. I hope you liked some of this. I hope you got something out of it. Did anybody here learn anything new? I'm hoping. Oh, good. Okay. Good. Are any of you going to go try this stuff out? All right. Very cool. I'm happy to hear that. I want to thank you so much for being here. Je vous remercie d'être venu pour, rester ici et m'écouter. C'est génial de votre part. Je l'apprécie beaucoup. Si vous avez des questions, n'hésitez pas à me les poser en français ou bien en anglais, mais je suis toujours disponible par email, par Twitter, à Starbucksman. Et merci beaucoup. Okay?
Well, we have thanks, Josh. Thanks, Josh. It's always good to see you and to have you here.
My pleasure.
Si on a encore 5 minutes pour 2-3 minutes pour des questions, ceux qui en veulent. Il y a encore des questions après off-site avec Josh. Oui.
Zool is deprecated.
Sorry? So great question. Is Zool, Z-U-U-L, deprecated? So Kinda. So the problem is that Zool is a Netflix project. Netflix has done a really good job with Zool. Please don't make. I don't want to sound ungrateful. Zool has been very, very good to a lot of people, right? It's been very useful. But Zool 2 is not moving. There's no evolution. Right now, Zool has some Zool 1 has limitations. It doesn't support other protocols besides HTTP. It doesn't support the reactive stream specification. And it has a weird API. If you've ever used it, then you know that you have to say, my class extends Zool filter, and then you have a method, public object run. Well, public object run, the object is useless. You just return null all the time. Nothing uses it. It's just a very strange API. It's not very nice. And also, it has, thank you, Netflix. Again, thank you very much for releasing it. But understandably, completely understandably, they didn't open source some things that people wanted, right? Like rate limiting. Completely understandably, because the way they do rate limiting is very specific to their use case. And there's lots of little holes, little gaps like this. And so the Spring Cloud team have, if you look at Spring Cloud, we have still Spring Cloud Zool, and there's a bunch of filters in there that we have provided to plug the holes. But all of these things are, eventually there's just enough reasons that we just said, okay, well, we can build something on this brand new Reactive Web runtime. We can provide a nicer API. We can support other protocols besides HTTP. And we can fill these holes without waiting for Netflix to decide maybe to continue or not to continue. So we decided to do that. So Zool isn't deprecated, but if I were building an application today, I would use Gateway. Great question. Thank you. Other questions? There must be some. Yes, sir.
When moving from a set of microservices from the Spring Boot web,
Yeah.
can we mix the version like about Eureka server and client?
Yeah, yes. So can you mix the versions of the Eureka services and the middleware and the clients? And yes, I think you can. The config server should be okay. The Eureka server should be okay. The Hystrix dashboard and the those things should be okay. Yeah. By the way, let me be very clear. I showed you Spring Boot 2.0 and the reactive web support. But if you're using Tomcat and you are doing lots of small transactions and they don't require the support for reactive programming, just continue using that. It's fine, right? You can still use Spring Boot Starter Web and Tomcat or Jetty or whatever you're using before. That hasn't been deprecated. Nothing is gone. So, if you are moving to Spring Boot 2.0, maybe you just move to Spring Boot 2.0 to get amazing ASCII artwork. It's fine, right? The ASCII artwork could be the reason. I don't know. You have the Louvre here, right? You understand the art of ASCII. So, yeah.
Okay. Thanks, Josh, again.
Thank
Merci.
you so much.